I apologize that we're having some technical issues and my camera is not working, but the important thing is that our speaker's camera is working and you will be able to see his slides. So thank you for joining us. As many of you already know, my name is Tom Herron, and I'm involved with market transformation at NFRC. And as part of this initiative, we bring you our Emerging Technology and Sustainability webinar series to deliver the latest thinking in fenestration and green building industries, along with insight on market trends. So today's webinar is entitled A Window into Innovations in Buildings, from Decarbonization to Offsite Construction. Our speaker is Mr. Ryan Colker, who's the Vice President of Innovation at the International Code Council. Ryan directs the Center of Focus on Energy, Resilience, and Innovation, where he identifies emerging issues in the building industry. He also serves as Executive Director of the Alliance for National and Community Resilience. Ryan is the former Vice President of the National Institute of Building Sciences. He also serves as the Manager of Government Affairs at ASHRAE. Ryan holds a Juris Doctorate degree in Environmental and Administrative Law from George Washington University Law School and a Bachelor of Arts in Environmental Policy from the University of Florida, Gainesville. If you have any questions along the way, please type them into the Q&A box rather than the chat box. And finally, we're recording today's webinar and we will post it on NFRC's website. So with that, I'm confident we all have a lot to learn, so I will hand it over to you, Ryan.
Thanks so much, Tom, and really do appreciate the opportunity to share a little bit about sort of, from my perspective, where I see things happening within the buildings industry, and then also maybe a little bit of opportunity on sort of how the NFRC community in particular, can be engaged and what you guys should be following. So as Tom mentioned, I'm Vice President of Innovation at the Code Council. Really, through the Center of Focus, have an opportunity to look at sort of what's happening within the industry broadly, identify some of the key challenges, and ideally identify solutions. Really looking across the ICC family of solutions to identify, strategies, tools, and resources that we can really provide, to the industry to address a lot of the problems and challenges, that we face as an industry, but also, that society in general, is facing as a whole. So I think, sort of most folks are familiar with ICC as, the developer of model building codes, International Building Code, International Residential Code. But really, ICC is what we call a family of solutions. So really looking sort of across the regulatory landscape, the building landscape, and really trying to provide solutions that make those codes and standards effective, support their effective implementation. And so things like, personnel training and certification, product evaluation, accreditation services, digital solutions, community resilience benchmarks, which is primarily the work of Anchor, or the Alliance for National and Community Resilience, which Tom mentioned, and third-party evaluation services, a lot of that actually happening in the offsite construction space, which we'll get into. So today I'm going to cover, I think, 4 sort of key areas that we see as big challenges before us. Again, as I mentioned, some are industry based, some are sort of more societal, and certainly all of them sort of happen at the intersection of society and the industry. So sustainability or sort of decarbonization in particular is definitely an area of focus. Housing affordability and availability, huge issue that folks are dealing with. Workforce challenges, we've seen, across the industry, folks leaving the industry, not a whole lot of sort of new entrants. And so how do we figure out sort of new ways to leverage the workforce that we have, and how do we sort of attract, new folks to the industry? And then we'll talk about resilience, particularly to hazards, some of them driven by climate change, some of them, not, but certainly housing patterns and, some of the other challenges that we see, really sort of rely on buildings to help address, some of those issues. So sort of hitting on sustainability first, folks may have seen sort of variations of these statistics, but really looking at the impact that buildings and the built environment have on greenhouse gas emissions, energy use, fairly significant. So if we look just at sort of the energy used in the operations phase of buildings, that's about 34% of overall energy use relative to greenhouse gas emissions. But then if we look at sort of the energy related to sort of all of the processes, the materials and everything that go into buildings, that moves up to 37%. And so, really as we're looking to, reduce greenhouse gas emissions, it's hard to ignore the building sector. We can't really get to our climate related goals without, looking at buildings. And so we'll touch on some of the things that folks are working on to address those challenges. I think at the same time, as we have the sort of significant impacts of buildings across their entire life cycle, we're seeing shifts in the energy grid, moving towards less carbon intensive energy generation, which then sort of creates an increased focus on actually the materials and sort of what goes into making those materials. And so sort of lots of dynamics around sort of building decarbonization, and a lot of sort of various different strategies to help address those impacts. And including from the White House and other agencies across the country, but even around the world. So we have the White House sort of aiming for 50 to 52% reduction in economy-wide greenhouse gas emissions by 2030 from a 2005 basis, with certainly a special focus on equity and assuring that those that are probably sort of most impacted by shifts in materials and buildings and all of those issues really have the ability to take advantage of any incentives or any sort of measures that really help reduce those impacts. And then sort of drilling specifically into buildings, White House has set zero energy building goals by 2030 for new construction, by 2050 for all buildings. And so really looking at sort of what are the strategies that are going to get us there from sort of the building industry perspective. We even have sort of key players within the construction industry really looking at the carbon impacts or the greenhouse gas emission related impacts of their work, including Arup and Skanska. I think the sort of important piece to this is they're not just looking at the operational aspects of buildings, but really looking across that entire life cycle, from sort of the early design process all the way through to deconstruction, which really sort of brings us to this graphic. Hopefully folks have seen maybe some variations of this, maybe not as colorful, but really sort of trying to parse out, what are the various different stages across the entire life cycle of a building? Where can we impact reducing, any sort of emissions associated with those stages across the life cycle? And then how do we start to think sort of holistically, across buildings? So, I think it's, probably pretty obvious choices that we make early in the design process certainly impact, how energy is used during the operations phase. And again, choices we make early on, sort of impacts the sort of ease of demolition or recycling or reuse of buildings. Certainly a lot of the conversation, that we're having today around transitioning, commercial buildings into residential space. Some of the very sort of early decisions made in the design process sort of determine, whether it is, effective for a particular commercial building to be transitioned into a residential building. And so sort of really grasping this sort of life cycle focus rather than maybe a sort of individual sort of piece of a building's life cycle to be more holistic and really understanding that impact. So thus far, we've seen some work in a few different areas. From the codes perspective, the operational piece has long been sort of an area of interest, of criteria, largely sort of coming out of the energy crisis in the 1970s, when we started to see sort of energy codes, energy standards come up. And so we've long had International Energy Conservation Code, provisions within the residential code, the plumbing code, to impact energy and water use. And then within the past 20-ish years, an increased focus on sustainability. And so, the International Green Construction Code, ASHRAE Standard 189.1, have sort of provisions focused on the operational side. And so, we really have sort of a good backbone for addressing, operational energy. We see examples of, zero energy buildings, increased focus on delivering, operational savings, during that phase. Haven't seen a whole lot of sort of activity in many of the other areas across the life cycle, except for some within sort of the embodied stages early on. So the design process, the products, and the construction processes used. So I mentioned the International Green Construction Code. Chapter 9 includes provisions around materials, including the use of environmental product declarations, which we'll talk about in a few minutes. But that's really sort of been the extent of, let's call it a holistic approach to sort of stages, A1 through A5 within the life cycle of a building. We've certainly seen on maybe individual products, standards and criteria around sustainability, but from a sort of a code level and an ability to sort of talk across products and materials, not a ton sort of previously, but certainly a lot of activities sort of ramping up in that space. And so, sort of really recognizing the need to have a common basis for talking about the life cycle impacts of buildings, ICC and ASHRAE come together to develop Standard 240 on the quantification of life cycle greenhouse gas emissions of buildings. So, how do we have the conversation? How do we assure that, sort of everyone across the entire life cycle of a building really have that complete picture? And so looking across, all of those different life cycle stages to be able to sort of pull all those pieces together. And so I think, one of the things that, has been a challenge thus far is really being able to communicate or understand sort of the trade-offs between embodied carbon or embodied greenhouse gas emissions and operational greenhouse gas emissions. Not, particularly sort of focused on fenestration, but, one typical example that I think folks, understand is around insulation. So, some of the insulation products require, pretty significant sort of investment in embodied carbon to create them. But, the sort of operational side, you reap the benefits of good insulation, from that initial investment. And so, how do you sort of trade off, or at least sort of understand the impacts, across those two sort of different life cycle stages to really be able to, drive towards a holistic understanding of impacts. And so, sort of being able to communicate that both within the buildings industry itself, but then also, we're seeing calls from, real estate companies, from financial investors, even governments, including the Securities and Exchange Commission, to look at sort of how do companies report their environmental impacts. And so, from a building sector, having a consistent approach is really important to being able to communicate sort of, where we are as an industry, where individual sort of buildings or portfolios are headed. And so, We are working on an accelerated timeline for development of Standard 240. We actually have a public comment period currently open through March 18th, and it would certainly encourage folks to take a look at the public comment draft and provide input. And so, some of the things that, we're seeing, particularly around sort of embodied carbon or embodied greenhouse gas emissions, is sort of a pickup in policy interest at the state and local level. So again, sort of having a standard like 240 hopefully supports consistency, across those various different programs, but also, sort of is really driving the conversation to really understand further, what are the impacts. So Carbon Leadership Forum has put together a map sort of outlining, where these various different activities are happening, and sort of, what are the different flavors of programs that folks are looking at. So, as I mentioned early on, we haven't seen necessarily a strong focus on sort of embodied carbon or embodied emissions yet within the buildings industry, but as demonstrated, by this map, certainly, those policies are picking up in interest and activities. And so what does that really mean for, the glass industry, fenestration industry in general? One of those sort of programs is from U.S. General Services Administration, really looking at the impacts thus far of 4 particular materials that are used, in large quantities in the building industry. So concrete, asphalt, glass, and steel. And so what GSA has done, and what we'll see likely in other communities, is really setting maximum limits for the greenhouse gas emissions associated with the creation of those products. And so GSA has released interim guidance on or requirements for those 4 materials. I've put up the one for glass. At this point, focused on flat glass, but as all of you know, flat glass appears in many other products, and so sort of understanding the impacts and the really the limits of greenhouse gas emissions associated with those particular products is becoming increasingly important. And so these limits are really set by data from an environmental product declaration. So we'll talk in a second about sort of what an EPD is, how it works. But really what GSA has done is sort of looked across the industry, looked at available EPDs, and determined sort of what's best in class, what's sort of better than average. And they're using that to set limits with some sort of recognition that regional availability of particular products may differ. At the same time, we're seeing a significant amount of funding from Environmental Protection Agency to help enhance the availability of EPDs across the industry. They just closed a funding announcement for I think close to $100 million to help sort of drive the increase in environmental product declarations available in building related products. And so this is an example of environmental product declaration, really sort of a nutrition label, with maybe some additional sort of information. So I pulled this one from our ICC evaluation service, which is a accredited EPD program operator. Basically, they look at life cycle analysis and some of the underlying data of sort of where our materials coming from, what's the energy expended to actually produce those materials, and so providing those again as sort of a nutrition label, but also with a lot of background on sort of where that came from, and then a designer can sort of make choices based off of the environmental performance of a product, depending on their particular need. And so EPDs really provide that sort of uniform basis for understanding the environmental impacts. And so just sort of a snapshot into the EPD development process. I mentioned, ICCES is a program operator for each product category. So, a similar sort of type of product. There's a product category rule. So, how is that product going to be measured relative to the generation of an EPD? And so I think the important piece here is that you're comparing sort of like product to like product. You're not comparing sort of across different materials. So sort of the easiest example of that is, concrete versus steel. You can compare sort of two mixes of concrete to each other, but you can't compare concrete to steel because there are sort of different rules on how each of those products are measured. And so based off of that product category rule, life cycle assessment would be done to sort of build out that nutrition label that I talked about. And then the environmental product declaration sort of boils that down into something that designers and jurisdictions can use. And so the program operator really does that verification, third party validation of that EPD. So, I think one important thing and one that we've recognized is that, environmental performance is certainly a key performance attribute, but there are definitely other performance attributes, that need to be considered as part of, design choices as well. And so how do you sort of bring all of these pieces together? And we see that as, sort of the role of codes. We see that as the role of, ICC evaluation service, other evaluation bodies to really be able to sort of bring all of those performance pieces together and really understand, what is the sort of holistic performance across all of the things that we care about, relative to sort of different building products and different building materials. So shifting a little bit to sort of the resilience conversation, this is a map of the disaster events that have caused $1 billion of damage or more across the U.S. In 2023. As you can see, significant number of such events. In fact, breaking the previous record, which I'll show you on the next slide, pretty significantly. But these are just the $1 billion disasters. There are certainly many more disasters, at the community level that may not reach, $1 billion, but certainly have, strong impact, on those communities. And so being able to sort of recognize those impacts, buildings are often shelters against, those various different hazard events. And so, assuring that the built environment can continue to protect folks from these disasters, particularly as we see, some of these increasing in number, frequency, or intensity due to climate change. And so sort of, again, sort of that intersection of sort of decarbonization and resilience, and really sort of seeing the sort of two sides of the same coin, where we really need to sort of understand broader building impacts to hopefully sort of reduce the impacts that these disasters are causing. And so we clearly see sort of this trend in the increase in numbers and impacts of disaster events. So these are the costs. As you see, sort of the colored lines are sort of more recent history. And so, you can sort of clearly see the sort of growing impacts of these events. Some of them certainly caused by an increase in the number of events or the sort of intensity events, but I think also maybe a little bit reflecting on sort of the growth in communities in particular areas where they may see enhanced disaster risks. So while 2023 was not a record relative to sort of the impacts or the cost of such events, it far exceeded all previous years. I think with 28 such billion-dollar disasters. And so just thinking about sort of the impact that that has on communities is really strong. One particular area that I think may be of interest to this group is actually from a study that the U.S. Department of Energy, Pacific Northwest National Lab, and other labs did relative to the impacts of things like energy codes on what's called passive survivability. So if you have a disaster event in conjunction with an extreme heat or a cold event and the power goes out, how long can people stay in buildings comfortably, without increased death, increased injury, or even sort of increased pressure on heating or cooling shelters, those sorts of things. And so this is just a snapshot of some analysis they did for Atlanta. The orange color is sort of existing building stock. The purple is if the current edition, the 2021 of the International Energy Conservation Code was applied, and the green is enhanced provisions, in this case, passive house. And so you see sort of that dotted line drift down with these improved envelope measures, meaning that, if that line is below sort of that shift in temperature, that sort of enhances the inhabitability. And so you see, with the IECC application, someone can stay comfortably in their house for about an additional day, 3 days, if they follow passive standards. And so, sort of thinking about the improvement in building envelope can mean more than just, sort of kilowatt hours saved, but also can, impact the survivability in a disaster event. Another area, particularly, sort of relative to affordability, workforce, sustainability, that we see as a real opportunity to help drive the industry forward is offsite construction. And we'll talk a minute about sort of what offsite construction is, but, it's really sort of an opportunity to sort of shift the paradigm on, sort of how construction process works. How do we address a lot of the challenges that we're facing, both as society and as a building industry? And so, time savings alone from use of offsite construction can be pretty significant, which often cases, leads to cost savings or getting folks into housing quicker, which is certainly a challenge. And so, we see offsite construction used in a variety of different ways. Things like shipping containers, volumetric modules, bathroom and kitchen pods, panelized systems. But sort of the common thing about offsite construction is, sort of whatever shows up to the job site is closed in or, sort of considered closed construction. So the local inspector, can't really know sort of what's happening behind the walls without sort of destroying, sort of what was done in the factory, which then, sort of defeats the process or the benefits of offsite construction. And so, the offsite construction really, presents an opportunity to, fabricate large chunks of buildings, in a factory environment, opening up opportunities for less waste, increased quality, and attracting, new workers to the industry. So, if you're working in a factory environment, much more sort of comfortable. You don't need to be out in the rain or the snow. Everything is, within arm's reach. Sort of the most you have to do is sort of climb a 6 or 8 foot ladder. And you have, cranes and forklifts and sort of all of that stuff, right at your ready. And so, while we see offsite construction as, a significant opportunity, certainly some challenges. So this map really captures sort of how, at a state level, jurisdictions deal with offsite construction. And as you can see, certainly a smattering of different colors, which means that, the all the states except for the ones in orange have a statewide program. So all offsite construction elements flow through those statewide programs, which is great for consistency. But each of those programs operate a little bit differently. So, do they allow third-party plan review? Do they allow third-party inspection? Both, neither. Do they just cover commercial projects? Do they just cover residential projects? Are they only covering full volumetric systems? Do they cover panelized systems? And so, if you're thinking about sort of offsite construction as an efficient process built in a factory, and that factory may wish to service sort of multiple different states, those variations create some complexity to that process. And then the states in orange leave the entire offsite construction approvals process to local jurisdictions who likely have never seen an offsite construction project before. They don't necessarily have the resources to be in the factories, which could be hundreds or even thousands of miles away. And so, if we're looking at advancing offsite construction, being able to sort of bring some consistency to that process is really essential. And so, really recognizing that need, ICC, working with the Modular Building Institute, has developed a suite of standards to help hopefully sort of bring some best practices and consistency to the offsite construction space. So standards 1200 and 1205 are really the core, providing sort of the basis for the design fabrication process in 1200, and then the inspection and compliance process in 1205, really working hand in hand. Pleased to report that Salt Lake City, Utah, and the state of Virginia have already adopted standards 1200 and 1205. Conversations are happening in multiple other states to, again, hopefully sort of bring some regulatory consistency to that process. And then standard 1210, which was recently released, looks at, in the offsite construction space, energy efficiency, water conservation, and MEP systems for offsite construction, and seeing, sort of where are there efficiencies that can be gained in the factory in that space. I think the important thing to note when we talk about offsite construction is it still needs to comply with all of the requirements or the local, sort of building code that's adopted in the jurisdiction where the building will ultimately be set. But as you can guess, the challenge is, the sort of traditional inspection process doesn't necessarily work because what's showing up at the job site is closed construction. And then we're actually finalizing publication of ICC Guideline 6 on advanced panelization for buildings, which is probably of particular interest, to this group, which I'll talk about in a second. But we've also seen sort of an increase in interest in tiny houses, lots of confusion, what standards apply. Does it need to be built to the requirements in the International Residential Code, including Appendix AQ, or are other standards like for RVs or park models appropriate? And so we've developed a host of resources to really help address some of that confusion. Really, with sort of the description that if a tiny house is going to be used as a permanent residence, it should follow, the same requirements as any other permanent residence. So that should be, the IRC, whether it has wheels or not. And so we are in the process of developing actually ICC THEA, Tiny Home Industry Association Standard 1215, to really help bring some consistency, to that space. So Guideline 6 really focused on opportunities to advance panelization. We've seen focus on panelization as an opportunity to advance offsite construction. The challenge has been that, because of that inconsistency at the state level, and just sort of general, I don't know, I guess we can call it nervousness of folks to sort of move towards a closed panel system, we haven't seen sort of the next iteration of panelization really happening. And so Guideline 6 really focuses on a approvals process that allows for enhanced automation, closed panel systems that really mirror more of a product approval, product listing, type of approach, really encouraging the use of sort of system-based approaches and providing manufacturers some flexibility. So really focused on, how do we get increased levels of finish on panels, including sort of integration of windows, air barriers, water barriers, and sort of allowing a sort of higher degree of closing up panels to really help drive progress within the offsite construction space, but particularly the panelization space. And so that guideline is actually complete. It's in our publications team right now, so we should see that in the next couple of weeks. And so this is just sort of outlining the process that we see for Guideline 6, where there's a approvals process, quality assurance process at the manufacturer. There's an approval body involved, like ICCES, and then significant traceability, across the life of that panel. We've also put together a whole host of other sort of offsite construction resources, again, to address maybe some of the challenges that we've seen, including a primer that really focuses on the various different types of offsite construction. Again, sort of panelized, volumetric, even manufactured housing, tiny houses, sort of what are the requirements, for each of those, types of processes. An FAQs document, which really sort of dives into a lot of the questions that we've heard from code officials and others on, sort of offsite in general. And then, specific resources on the standards I mentioned. And so, I've hopefully provided sort of a perspective on some of the things that are happening, within the industry, some of the sort of opportunities that we see for, sort of driving progress, some of the sort of strategies that could be deployed to help really move the industry forward, and hopefully, provide some solutions, that can help sort of, address some of those challenges, that I raised at the beginning, including sustainability, affordability, workforce-related challenges, and resilience. So happy to take questions. Happy to, sort of continue the dialogue. I don't know, Tom, if you have sort of any thoughts. I don't see anything yet in the Q&A, but happy to have a conversation.
Yeah, that's great, Ryan. Thank you so much. This is just tremendous information. Amazing graphics too, by the way. Those were really good and very, very, very insightful. One thing that stood out to me is the section where you talked about how important it is to look at buildings more holistically and the need to make good choices early in the design phase. That's just such a critical component.
Yeah, and I think for sort of too long we've been looking at sort of buildings as sort of discrete stages or discrete systems, and not necessarily sort of understanding, well, maybe understanding, but not paying too much attention to sort of how decisions are made and how they impact sort of the longer term building performance. So I think sort of as buildings get more scrutiny, I think we'll certainly see an increased focus on a more holistic approach. So I think that's certainly exciting, and ICC is certainly looking to help facilitate sort of the best way to do that moving forward.
Yeah, that's really great. I've been to some conferences fairly recently where they've talked a lot about this kind of thing, the building as an organism and how you interact with it over a long period of time, and how the most energy efficient and healthiest buildings might not necessarily be the ones that meet code initially, but the ones that perform well in the long run.
Yeah, so I think, as you mentioned, I think that conversation is certainly picking up. And it's not necessarily going to be sort of an easy transition. I think, we're seeing that sort of in the offsite construction space as well, where sort of it's a little bit of a shift in sort of mindset. But at the end of the day, hopefully we get sort of better buildings out of it and really help, address some of the challenges that people have recognized.
Well, this kind of education and perspective that you're providing is certainly going to help things along. I'm very confident about that.
Yeah, so always happy to talk to folks, always happy to share sort of what we're working on. I think there's sort of no shortage of need around sort of solutions, but certainly looking to do what we can to help move the industry forward.
That's fantastic. I don't see any questions. If anybody has anything, please feel free to drop something into the Q&A box. I'm sure Ryan would be glad to address those.
Yeah, absolutely. So Tom, maybe you want to share things that are happening at the NFRC level related to sort of any of these sort of topic areas I touched on.
Yeah, we're definitely trying to do more to bring these worlds closer together, tying NFRC to the bigger picture of the green building community and sustainable design. And that's one thing we'll be working diligently on throughout 2024.
That's great. And I guess
So, mhm.
I was just going to sort of make a plug that, sort of as folks on the call sort of think about sort of opportunities to engage, please, certainly, whether that's in, one of the standards that I mentioned, the code development process, if, you're sort of have ideas on new products, we can certainly help, navigate a lot of that. So, happy to be sort of a partner in trying to get to solutions.
That sounds great. I'm sure folks are going to take advantage of that, definitely. So if we don't have any questions, that concludes our webinar, and we will let you know about future sessions. Thank you all very much for being here. And thank you, Ryan. Excellent presentation. We really enjoyed it.
Yeah, absolutely. Thanks so much.